Hey, how are you? Good afternoon, all. Same as Kat, I guess. First, I want to test if you can see me, if you can hear me, because I'm not in the usual place. I always run these live streams. Um, Let me know if everything is good with the stream. You can hear me, you can see me. I'm in a very, very warm place, and the weather today it's insane. I'm just completely melting, and you can see by my face like I got this how to say it this feeling that it's just too much warm today. I can see you and I can hear you perfectly fine. Thank you a lot. So, thanks, Katagas, for sharing this link to the check-in. I always forgot to share this during the stream, but I share it on the announcement on the Discord, right? So please don't forget to check in events.mlh.io/events/1159, and we are ready to start because I started a little bit late. I'm sorry about that. Wait, coach, it's here, Alberto, and this very nice Mexican flag and this other very nice Italian flag. Uh, all looks good. So Green Yashik is around here. Amazing. Oh, that's terrible. Or he hasn't hit yet. It's actually been nice weather, which is odd a lot. Yeah, this time of the year, we're supposed to have a nice weather, but we don't. And weird things are happening here in Mexico. For example, we have this tree. I don't know what the translation is, but we call it jacarandas, and they usually don't bloom this time of the year. But right now, they are completely like the flower. It's just there, and they're supposed to be not. So many people are concerned about that. Also, right now we have a problem about not having water. Uh, so I don't know. I don't want to uh, starting to stress people here, but yeah, climatic change is a thing. Don't deny it. Let's start with the stream and how to prevent climate change, right? 404 also here on the house, so that's amazing. Very, very good audience, and I'm very excited to start this stream. Let me prepare some things here, and then we can start. We are going to continue where we left it yesterday, and that is on the Mozilla documentation, um, MDN web docs of Mozilla. And I think now we're ready to share. Allow and add to stage. Okay, here we leave it yesterday. And now we need to search for the game's post again, right? So what do we have it with the game, gamepad API, game over. Let's try with video games. Oh, but this is in Spanish. Let me change resource. No, it's supposed to be in English. I don't know why. I'll change it. Game development, right? And yeah, yesterday we leave it in this part. We saw some examples. We also see this part. But what I want to find, and I think I'm not getting success at that, it's to look for games. Um, what's the word? Framework libraries, techniques, push games. Maybe they changed documentation because at some point I knew they have like a full list of libraries and tutorials and stuff we could use. Maybe if we search for it on the WebGL API, because these are libraries that make use of WebGL, so it could make sense. Resources. Resources. Chronos, it's the main website. WebGL Fundamentals, WebGL Academy. Oh, yeah, here. Libraries. Amazing. Yesterday, someone, sorry if I don't remember the name, mentioned 3AS, for example, the one we see here. 3GS is an open source, fully featured 3D WebGL library. But the question yesterday was if 3GS was something similar to Play Canvas. I answered it was similar, or more similar to Phaser, for example, which is a library. Babylon, for example, Pixie, yeah, yes. Uh, but Play Canvas indeed is a game engine, which is slightly different. And we mentioned that, for example, this Play Canvas game engine works very similar because the concept is the same as Unity, as Unreal, for example. These ones are game engines that mean help you uh, to process things like physics, like to have a three-dimensional or two-dimensional asset and place it in a world and start giving texture, start giving a lot of things. Like that's how you develop games with the ability of having pre-builds, for example. Yesterday we talked about how we can do this fully from scratch using the WebGL tool from the web. But in this case, we are mentioning that it was hard. We just code an example of how to um, apply shaders to a rectangle that the rectangle doesn't even have movement on itself, and it was more than 3,000 lines of code. And we make another example of how to implement a game that got failing or raining rectangles, and we had a score and everything. We saw another example of how to implement a 2D breakout game, and again, that is starting to be complicated. Even with the use of other libraries, for example, we use one for the matrix of the rectangle, but that was hard. Play Canvas, 3GS, Babylon, Pixie, Phasers make that easier. But internally, they use this WebGL tool. So that's why yesterday, the whole yesterday session was dedicated to know what WebGL is. Right now, we are going to explore these. I planned it for being just Phaser, but let's do a little of 3GS, right? That will be cool. And on tomorrow's session, the third and last part of this series, we are going to explore Play Canvas, which is the game engine, right? So I'll share this if you want it for reference. Here it is. Oh yeah, Adep Hufor was the one who asked about 3S. So let's start with some 3S, right? You can go here to the resources section on developermozilla.org, docs, web, API, WebGL. and send the same and follow the same link as me, or just Google 3JS, and you probably see this library, right? And keep it with the lettuce. So how's the challenge going? Did you were able to complete the challenge? Do like what's your deadline for that? That will be a thing I would like to see. Okay, so we open 3JS and let's see what it has for us. They have a learn section on documents, examples, editor, GPT, community questions, code, GitHub, resources, fundamentals, journey. Let's start with the fundamentals. This is a hello world, right? So is this the first article of a series about 3JS? Again, 3JS, it's a 3D dimension library to try to make it easier and possible to get 3D context on the web page. 3JS is often confused with JL, since more often than not, but not always, 3JS uses WebGL. Oh, I didn't know that. Not always. I thought it always uses it. But again, recalling for yesterday's session, WebGL, it's a very low level system that only draws points, lights, and triangles. We did it yesterday, right? Remember that. With the help of 3JS, we are going to render a lot more than that. You will see in the examples that we have previously that this tool is very powerful and gives you like out of the box very very amazing results. Because let's say yesterday example, the rectangle, very complicated code was not that delightful to see on the screen, right? It was just like, okay, I could do it with CSS, but it was necessary to understand what's happening here. Well, learning the most programming languages, the first thing people do is make computer print hello world. So let's print this hello world in graphics that is the hello cube, same as yesterday. But in this case, the cube will be three-dimensional. So I recommend you to take a deeper look on this and read the full document by yourself. But for time's sake, we are just scrolling down to see how we can do this. And here, first we need to load 3JS. It's important to put the type model, but let's open or, well, in my case, Visual Studio Code and start coding this. Just give me a second. I'll stop sharing my screen. Okay, share screen, full window, and just give me a second. Okay, I think I'm ready to share. So now you should see Visual Studio, right? Yeah, right. Yeah, right. No, this is my hyperterminal. And this was yesterday example. So let's close this, and open the 3JS thing. And let's create an empty um, index HTML file. HTML5 document 3.js example. We need to open a new body, no, a new div to encapsulate what we're doing here, and then 3.js example, dim synth container. Okay, this looks like Copilot is working hard, but no, at the moment we just need to import a script. Type module, and the source will be hello box.js, and we need to create that file, hello box.js. And here we need to import what we were saying, right? But I want this import from 3.js, import as 3 from 2. Yes, this is the recommendation. This doing it inside this script, but I like to work in separate files. So again, it's important to use the type and everything. We're importing this inside our file, and then we need to add a canvas. So let's do that on the HTML. Canvas with an ID that will be canvas. That's fine. And on our script, we need to call a main function. Remember, from yesterday, we saw there are several ways to do that. We could just call this inside a self-declare, self-use function that will be function. But let's do it the old way, right? So just function main, don't receive anything, and we need to call this main. What else? We have a const canvas which has a query selector. Again, we get from the file, but we need to call it canvas as we call it that way with our ID. We had this render that gets a new instance of 3 WebGL render. And after we look up the canvas for the WebGL render, we need to add some camera perspective information. Let's do that, copying this. And this explains what we're looking at. And we add this here. What else? A camera.position. And everything. So when created a basic material, well, more, but we want this example here. Right, so let's clear this and update. We have our canvas. We need to update this because we call it different. Ours, it's canvas. We have our canvas instance or render instance from the WebGL render. What else? Our fav aspect near far, and we set that to create the camera. We can separate this to be more legible. We set the camera position, and we create a new scene. again from the object tree.scene, we have to get some box context for this, a box width, a box depth, a box height. We can play with this to be, I don't know, for example, to make it wider, and we set that as a geometry. Finally, we need to create the cube with the property mesh, passing the material of the object and the geometry of the object. And then finally add that cube to the scene. And we render this and we set our main function. We can close this, and this should work if our HTML works as we expect. But we need to create this using the CDN. So in our HTML, we are going to, it has no CSS. Oh, it has no CSS. But let me just go before this and check on the documentation to a better way to import the library. So here we have it in the installation. We can do this via npm, but at the moment I don't want to use npm. So okay, project structure, we have this. Public. Okay, install via npm. What other options we have? Import from a CDN. Nice. So this is what we copy. Yeah. Run serve to start a local server. Okay, I will do this, but with the tool I had installed on VS Code, which is a live server. So yeah, I think that's all we need. I'm just going to add this script thing here, but after, yeah, let's see if this works as it should. So I'm start, oh no, I started a server, but I started it in a bad way. I need to hit here on index and open that index HTML with the live server. So this is the 3GS example, and let's get back to the console because this is not working. It was blocked. Okay, it's showing me course. So I didn't want to do this, but I think I must. I will open the console. I'll cd to the 3GS folder, and here I'll npm install this library. So what it's say 3, and we need 3 as a normal as a normal package, but also npm e minus d bit. And now I can remove this import. Okay. So now should work. Open with live server. Come on. Oh, no, it was an error. Okay, it was just no. Yeah, it was an error. Type error from the specificator tree. Okay, that's weird. Do I import it right? THREE. THREE. Yeah, let me check the package JSON. And yeah, I do have tree installed. Okay. Yeah, maybe I need to run this in a very specific way, which is npx. Sweet. Well, I mean, I'm suppose it was mandatory. So local port is this one, and I will open this now. And now let me see. Yeah, here's what I draw. Perfect. So let's update this. Let's change some things. I made it wider, but I want it like in the regular way. I want to change the color for I don't know, uh, red, green, white. This will be better. A red one. And let's check what else, because you saw this example took us less than, what's it, 10 minutes when I started to code. And this does the same as our 2D rectangle, right? Uh, this one I showed you previously. Look at this amazing, huge code. Like there's a lot of it. Again, 300 lines of code. This hello box took us in our main function less than 30 lines of code, that including, well, the packages and thing, and we were using beta to run the project. But that's cool. I mean, you're adding layers of pre-built things, but you're taking apart a huge layer of complexity, and this, if you remember in this example, we needed to create the set of colors, we needed to create the position buffer, we needed to create the vertex, we needed to create a shader, we needed to create lots of things, and we even use as our own language, which was GLSL, GL shader language, to get this done. In this one, we get via a great abstraction, which is objects in JavaScript, passed as more understandable things, what a camera is, what a canvas is, what geometry is, what material is, and we get an object, a shape, from a mesh, which is in this case a cube. But obviously we can add it to our scene and render it. And well, I don't know what you think, but I think this is more easy to handle, and you can understand it in a better way. So using this library, which is 3es, we get our rectangle example in a more simple way, and in better way. And well, I will not say better, because remember, then you can thought, so why WebGL matters, because you want the performance thing. But in this case, the rectangle is a very simple example, and you don't care about performance maybe. So returning to this, or community, no, or fundamentals showed us how to render this hello box, right? I just want to quickly open a more complex example. Look at how this is working. I want to open a more complex example to analyze the code and see what big differences are, and to see the real powerful of using 3ds, not only to drawing squares, but to do complex things like this. Like if you want to put rotating a square with pure CSS, well, good luck. Uh, it's possible, but good luck. Um, Here, more rectangles. But I will check for, well, if you're familiar with three-dimensional assets, you probably see these OBG files, these GLTF files, and things like that. But okay, I will go back to these examples, and let's open a good example. This one looks really cool. So here we will have the code. This blank HTML style had. Let me see where if they separated it. Yeah, no, here it is. Okay, let's try to replicate this example. And we are going to create a new file called animation.html. And this will be the whole file. And see what we are doing. 3JS using WebGL, animation, and skinning. So first we need some metas about the viewport content, link to the CSS real sheet, but I have to create that too because we don't have anything similar. I'm guessing it's around here. Okay, maybe not here. What is the name of that? Main CSS. Yeah, this is the one. Oh no, yeah, it loaded now, so we can come here, take its example, and get it running. Create a file called main.css. Copy this. What else we need? Let me check the stream just to see if any any questions this far. Yeah, some questions. How's browser support for the type model? Um, what do you mean? Like specifying the type of JavaScript file we're saying it's model, or sorry, I didn't get the question. Wait, I'm so sorry. If you mean like for the library, they have a support table where you can check if your browser supports the library, and it's huge. Well, it's related to if it supports WebGL. Yesterday we were talking about the compatibility table about which browser supports WebGL and which features of WebGL. More browsers they tend to all support WebGL, but if you're in doubt, for example, if you use Chrome, Opera, Firefox, or anything, should be fine. Do we need to install 3 as a dependency? I tried to not, but I tried to use it as a CDN. It's possible if you give the right permissions to your browser to use unknown third-party code. But in my case, to protect from any other things, it has a course protection. So I had to install it as a dependency. Yes. Hi, could you remove the pop up on your screen? Yeah, sorry, it was bothering me too. I don't know where to put this, but I remove it now. Um, Alberto is now showing you how to import the dependency without installing. Yeah, I it was the plan, but in this case, I needed to. I mean, if I use Chrome, probably you should be fine to do this CDN thing. Um, Alberto, don't forget to change the version in the import URL. Oh, yeah, that maybe I think, but in this case, I used the npm package, so it was cool. Import should work. Just need to replace version with the correct version number. Too bad we don't have TTC. Yeah. Okay, but that's cool. Everything's working now, so thank you a lot. And I didn't understand the thing about the this browser support for the type module. So if you want to go deeper in that, or if I already answered that, it's fine. So, great to see lots of comments. If you have any questions, just put it here on the chat. I will answer it. So we can continue now. Yes, Peter works great with 3G. Yes. Okay. Awesome. Oh, here. So let's continue with our animation example. Now we have our style sheet with the CSS, and this style. I don't like this red. Let's call it black. Then her head, body, it's a container. This div has info, and then we create our script. Um, the import map imports 3js from build 3js model. I don't have build. 3js add-on is this JSM. I probably need to replace this. Let me check if we have a folder called JSM. Yeah, we do. Oh my god, no, this is a very complex. Uh, yeah, I don't think I'll be able to run this because it requires a huge carpet folder. Sorry, plus these assets I don't have. But I mean, we can take a look to the code. It doesn't harm anyone. Let me just close the beta example and close this. And let's see what this contains. This is a skeletal animation of blending model from an author called Mixamo. Let's take a look to his page to say thank you for giving us your example. Oh, it has an Adobe page, motion capture, or this is no. So this is not the author. This is a tool for Adobe, I think. So then we can close this. Note crossfades are possible with blend weights being set up to this thing. Okay, this model is from Mixamo. I thought it was an author, but apparently it is a thing about Adobe. Um, so we do the right imports. We set the tree from treeas library, and we import some more add-ons for from the add-ons treeas have, and we set some things we previously saw as the scene, the model, the camera, but we add more things that it's the renderer, the skeleton, the clock, and the statics. Once you work with environments of video games, you start getting familiar with some things like this. For example, the renderer, which in this case it's like I'm guessing because I haven't seen this example before, but I'm guessing they say the renderer will be like how they apply the textures to the skeleton and how they will be rendered every time in each frame. So we continue to discover if that's true. Then we have an init function. Yeah, it's the same as you call it a main function. The create panel function. Let's see what else we have. The show model, the show skeleton, the modify timescale, deactivate all actions, activate all actions, pause and continue its movement, pause all actions, unpause all actions. Uh, Singleton step model, prepare crossfade, set crossfade duration. Wow, synchronize crossfade, execute crossfade, set weights, update the weights of the sliders, update across the fade controls, on window resize, animate, and that's all. You'll see this is a big file containing 500 lines of code. Well, yes, including a little bit of HTML, but indeed, this is fully JavaScript. And let's see what that means. For example, we have a control panel here, and many of these options are referring to set and to update um, how the model it works, or how this is rendered, on or what actions that does this skeleton performs during the animation, right? So we can check it. We even have a FPS indicator here to show performance. We have another thing I like, to be honest, talking about performance. It's consider one thing. I'm streaming. I have opened at least three browsers right now. I'm using the camera. I'm not connected to internet via Ethernet or anything. I'm streaming via Wi-Fi. I have opened, I think, Word. I have VS Code, and I have a lot of plugins. I have to say. Um, and you see the fluid of movement of this character here, of this skeleton, and we can now, for example, show in visual graphics what this skeleton refers to, because remember, you can see the model, but the skeleton is like this linkage that actually performs the movement. Now we can deactivate and activate all of actions. Let's deactivate all. you see the skeleton is fully paused, then we can pause or continue. But first, we need to activate, I think. And this is just the animation flow. Make a single step, and you're not seeing this, but you can, for example, like clicking right now, click, 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 going step by step to see what's happening. Then I continue it just in the flow where um, modify the step size to make it more fluid. For example, I don't know if you see the difference here, but if I increase this, it's like a wider movement, uh, what else we can change? From walk to ideal, from ideal to walk, from walk to run, and from run to walk. You see how even the animation of the sliders work? Like, I know that's not an animation, but we're showing how these values change. We can change general speed and stuff, and that's all possible thanks to pure JavaScript. I mean, there's not much of how uh, 3AS performs this, but on how we can get the information of the interface. And we're using that thanks to the GUI, and that's an add-on. So we have the GUI. Let's look for this on code. Where are we implementing this? We have a GUI interface, a UI instance that we call panel. And from the panel, for example, we are adding this visibility, these controls, this activation, this pausing. So another good advantage, another great advantage, I will say, of using this type of libraries is that not only the library itself it's great and helps you to improve and helps you to develop quicker, but they are very popular among the community, and the community, as every open source community, create very common and very useful tools to us as gaming developers, and or me as a web developer. So you probably need a panel like this in some project you're working. Well, the good news is someone else needed it first, and you don't have to code it from scratch, but you can take it as an add-on for 3AS. Same as skeleton, same as the loader, same as better tools to help you increase performance. So this very huge code will be much wider and much complex without the use of these pre-made tools. So let's take a look to more of these functions. In particular, I want to take a look to the one saying animate, because this is how we're rendering the full 3ds tool. And I want to see if I can collapse this all. Yeah, I cannot change the perspective of the camera, but let's take a look to the camera. Where are we using this camera? Scene camera. Camera, it's 45 degrees from the window, and it's wide. So we are looking at this animation in perspective. That's the reason why I wanted to run this, because I wanted to change the values to see if we can change the perspective of the camera and see it in many view angles. But well, this is a very complicated example, and even though it's a very complicated example, not for the logic, and we were talking about this yesterday, not only for the logic, not for the uh, coding thing, but take a look at the textures, take a look at how the model it's built. And for example, here I'll deactivate. The body was built this way. Then we add at the skeleton, and we say like, hey, now position your arms here, and now position your legs this other way. You can move, you can interact, and you can um, give the appearance that you are fully linked body. Like you have freedom of movement. What's the word for this? The degrees of freedom on your links, and that's the complex thing here. Not only for the code, because as we see, we are using not that complicated concepts. We are using add-ons to create the panel and to get information from the things, from the HTML, from the the user interface, and just passing it to to the controls we created. But again, the complicated thing here, it's about the aspects, about the the graphic thing. Uh, but I think that's a very good example to continue. So we are going to move to another library, which is the phaser library, because in this case, again, 3ds it's more a tool for complicated graphic things, and you will see the difference. For example, if I return to the 3ds main page, you will see this is more focused on the graphics. This is more focused on, for example, how you present product, how it's rendered. um, well, it's really good for that. I've seen personal web pages using 3ds that I found fantastic. I found amazing. But remember, we're focusing right now on the logic. So let's call this a session for those one who are focusing on one or another. But even for those who want a little bit of all. So let's open Phaser, and this is a desktop and mobile HTML game framework. We can download this or fork this to get started, but I want to show you first some examples. For example, using React and TypeScript. If you're a fan of other frameworks like Svelte, that's really cool to go. We are going to use one of these React templates, for example, this Vue.js template, and wow, that's really cool. So let's close this, and first let me see if we have more comments here on chat. Iraq looked like most modern browsers support importing type models now. I haven't used import map before. It's cool. Oh yeah, so it will have. Just give me a second. I will come back. Just 2 seconds. I almost forgot to unmute me. And yeah, so I was saying, yeah, thank you, Wei. That was the 2 seconds. So thanks for counting that, and thanks for giving me the opportunity. I just wanted to sneeze. Again, the weather is not that good here on the city right now. Plus, we have lots of pollution, but I don't know how to say this. Like ash from the volcano we have close. Uh, the name is the Popocatépetl. So it's really insane. The air it's thick and it's hard to breathe. So well, Oh no, wear masks. Yeah, probably will will be a very good idea, but sanity's institutions here didn't tell us to do that. So yeah, I probably start doing that myself. But yeah, let's continue. Right. So again, let me present the screen. Go back to the browser. Close the 3GS, 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 and this was the example we just ran it. Let's try to do the same. Um, it's powerful, blah, 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 Pixits and open source to WebGL render faces with fast free open source for Canvas and WebGL power browser games. Let's take a look to just quickly Pixies. Um, Again, with HTML, we can do amazing things. Take just see the examples, start exploring yourself. Here, for example, I don't see much creative thing. So I haven't tried Pixies. I don't know why I opened this. Babylon, you saw, I opened it to check it, but I don't know. I didn't like it that much. But let's return to Phaser. I just want you to check the other opportunities or the other options you have. GL Matrix is the one we used yesterday with rendering of the rectangle example. Um, I don't know why this isn't highlighted as open, but no worries. Let's take a look to the what was the word? Hello box example here. So I will open Visual Studio again, close all of this, and create a new folder. No, create a new folder called Phaser. And inside Phaser, I'll create an index HTML. And here we will use the, let me see if they have another example. Just not to use the React template. Oh no, this is a Phaser is a JavaScript that you include into your web projects. You can download it, fork it, or use it as CNL instead via npm. Let's try to use it as a CDN, and if that doesn't work again, thanks to my browser, we will use it as npm. Getting started, Phaser Games code exclude JavaScript or TypeScript in an editor such as is code, blah blah blah. We know about this. Discover the features, make games, and publish. This is very important, and we almost forgot about mentioning this publishing thing. If we go back, but very back to the Mozilla web developing tutorials. Oh, I went too back. Let's change this to English. They have a dedicated section on how to publish games here. This is a huge topic because you probably are developing games just for fun, just to learn, as me, but it is important that if you want to monetize using these tools, give a good read to this section. I mean, for example, if you create a game specifically for Android, you may know like the publishing rules on the Google Store, or if you do it for iOS, you probably need to be familiar. Well, not you probably you need to be familiar in order to publish that on 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 what's the word for this on the App Store. Yes, but yeah, you will have to decide which distribution method you should use. They have good sections right from developers that happen to have problems with this, trying to help you in the way or in the path to publish your games via these stores, or if you just want to publish it in the web, what are the regulations about that, how you can monetize that. Well, I just want to make that for example here the game monetization section. I just want to make a parenthesis to give a shout out to this section, because many of you may found this very useful, but that doesn't concern to us right now. So let's return to the creating the video game itself. So, uh, Lauren, let's start on how to make your first game. And we want this on English. We know what phaser is because we know what um, WebGL is. A requirement contains each step of this tutorial. You need to have a very basic knowledge of JavaScript, because someone yesterday was asking like, what happens if I don't know what JavaScript is, or what a JavaScript is, how to code a JavaScript. Well, it's not really, it's very basic knowledge in this case, because yesterday JavaScript was very complicated, I have to say. Also, make sure that you have gone through the get started guide. That we are going to skipping that. So the first thing is construct an HTML that goes like here. Well, let's see if the CDN actually works. Oh, what was that? Okay, returning here. Here and here. Let's copy all of this and even the assets. Okay, nice. Now we can close. And now say open the part 1 of the HTML page in your editor. So let's do that. This part 1 includes some scripts that has a function, a configuration of the new phaser interface. It is downloaded via the CDN and has just inside the body the script. So I don't know what this works for. Okay, they explaining the difference about the different versions of phaser, but now we want something that indicates us this is actually working. Let's load the assets we need to for our game by doing this call phasers inside the same function called preload. Phaser will automatically load this. Currently preload function, it's empty. Okay, let's see if this part 2. Yeah, so it is step by step, actually. In the preload, they add the load image, and sky from the assets. The ground again comes from the assets, and well, they give it all the assets to us. So that's a good thing. If anyone doesn't know what a sprite is, it's technique for example, in the same image, you take three uh, fragments of a fire, for example. And in the first part, it's small. In the second fragment, it's medium, and the third fragment, it's big. And then you say, for example, to these type of functions that already has the preparation of a sprite, that every fragment has a width and a height. So in this case, it will take the first, the second, and the third fragment of the example I'm giving and run it quickly, so it will give the illusion that the fire is burning, right? Like the fire, it's increasing, then reducing, then increasing, then reducing. So you will think it as how a movie works, frame by frame. And in this case, it's the same for the video game. Remember, because we have frames, we have to to set this on a canvas. We have to run each frame, etc. But in this case, in a smaller version of that, which is the sprite sheet. So that's what this is. So we have the image for that, and we add the create image as the sky and the stars. Oh, we didn't add the stars. So now what else we have? We need to add physics, right? And we need to change the configuration. Let's see what it changes. From the configuration, we have a width and a height. We had physics, default physics for an arcade function. This arcade gave us a gravity value of 300, and the book false. The scenes calls the preload with the preload function, the create with the create function, the update with the update function. We can change the names of this, but by convention works this way. Then we create the game with the configuration we just mentioned, and these games needs to be executed by the update, but we haven't get that far, right? So let's keep moving. On the preload, we know we have these images in the assets. Then in the create, the platform, what's the platform? We know what the player and the platform variables are, but we declared the platform as an object inside the game that will have certain rules. In this case, where the character is going to move, so it cannot be pass. I don't know. The player cannot go through the platform. It needs to serve as a hitbox, to call it in a way, so the player can jump in the platform, can do things related to the platform. And we have the background for this will be the sky. These sky images, we have it from the assets. So we create the platform as the positions, and you say it's the ground, right? So then we create a player, the player sprite. So in this case, it will give us the illusion that the character is moving, same as the example we saw on 3AS. For example, this 3AS thing was a very complicated one because it had a skeleton. It actually moved articulations, and that was like very hard to process. And in this case, we're just building a very simple arcade video game. So the player, or the object that is the player itself, it's not going to move. So, but we are going to change the image showing to the player. So not this player, but to the one moving the the character. So it will give the illusion that actually it's moving. You know, that's the thing. So we set out a bounce. We set the collider to the world because we don't want the player to go outside or canvas. Then we create the animation, and well, we need to go to the next part. I want to get to the part when the update function is called. Yeah, here. So every time and every minute of the running a scenario, we need to hear for the user input. In this case, we are going to use the cursor, the right and the left buttons, and these how to say it. The, no, not the right and the left button. The cursor to go left or right, sorry, and to change and to set the velocity. So let's go to the final part to talk more in depth about this. What we do with this hearing of the update, it's we set the actions to the player. We previously mentioned that it's the one here that already has the animation of the sprite, that has the bounds, that has the colliders, and we created on the event. And finally, what we done with the game, well, if the game is over, we return this to zero, and that's the static. We need to collect, we add a function to collect stars and to hit the bumps. In case we hit the bump, we set the game over flag to true. If we collect stars, we add a listener to increase or decrease the the score, to say it some way. What else we have around here? The physics that adds to the player, to the stars, to the bombs, to the colliders. It's the same as we mentioned about the platform and the player. So it works very similar. And the last thing, it's about this. Yeah. So, well, it doesn't matter. Then we have, once we declare everything, we initialize the game, we call our preloads or creations and or update function inside of these three principles. We set to um, functionals, to functions to help us manage logic inside this. But once we have all these three principles, then we can run this project, and we will do it. Let's see, using live server, since we have the CDN. Let me check everything fine on console. Yeah, so now I'm playing using the buttons on my computer. I can jump. I have these stars, and you see the sprite I mentioned. It's very useful, right? So I'm going to touch the bomb to activate the end of game. Oh no. Now the bomb doesn't want me to touch it. Wow, I'm chasing the bomb. It's hard to lose here. Okay, now take attention to what happened to the character in the bomb function. Hit the bomb. We set the physics to pause the game. To the player object, we sent a tint of red. We can change it to be blue, for example. and the animations play turn and the game it's over, right? So let's reload this. And first we need to pause this. No, to change difficulty. Oh, I didn't make it. And I want to touch the bomb again to see what changed. Oh, RG. Oh yeah, I make it green. No, not blue. But just so, it's really simple. How these objects help, how these interfaces help us to set methods, to set attributes to the well, in this case, to the objects we're interacting. We can change, for example, how platforms works. For example, this principal one, it's the ground. It has the property of receive of being this length. But I don't know. We can change this for 100%. We can um, reload to see the changes we made. So I changed the position of this, and now I don't think it's playable. No, that didn't work. So I will make it this. So maybe I block the whole jumping scenario. I'll return to what it was. For example, if I see the dude sprite, oh yeah, you can see what I was meaning to. We have the principal line, so if we go to one side or to another, what we have is a listener to know what's happening there on the update, and the animations played left or the animations uh, played right. If anything else happens, I mean, if no cursor is played or the cursor is up and down, we change with the velocity. If nothing else happens, we say like the animations plays to turn. We have this key to declare these animations. In this case, the left means the frames we are using. It starts at 0 and ends at 3. That means this, this, and this, and this. If 1, 0, 1, 2, 3, 4, it will be the turn. For example, here the turn, it's the frame 4. The right, it's from 5 to 8. So that means we're starting the animations from this 5 frame and ending in 8 and repeat in loop. So it will give us the illusion that it's running to the right. So that's how its price works, and it's really cool. We only need to do this one time, so it's on the create function, same as the creation of the platforms and everything. But imagine, for instance, we want to change uh, the position of these platforms every time we change the how to say it, the level or the difficulty here. Let's do that. So how we do that? Let's go to the, let's close this. The preload, it is not necessary to happen in the update. Collect stars. Once the score, once we disable body, true, true, true. Set score, if starts count active true, it's equals 0. Starts children, a new batch starts to collect. Okay, here, if, for example, starts children iterate change enable bar player X, it's the score, it's less than 400, phaser map between Bob bomb create bomb set the bounds, blah 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 blah. So in this case, every time a new batch of stars it's for collect, we want the platforms to create, but in different position. So platforms that create, but here will be phaser dot mat dot between. And which positions could we use? For example, this is from, okay, let's do it from 0 to 600. And we will do this same for this second one. And give it the ground thing. So let's see how behaviors. I think it is going to add the platform, but not. It is not going to delete the previous one. Now I think of it. Yeah, it added a new one. But we need to delete the previous ones. That's a good thing to know. So maybe. Oh, okay. What else? We need to delete the previous ones. So let me just, on the creation, that's the good thing about being in JavaScript. We can console.log platforms and say current platforms. And I want to see if there's a way here on how to delete them. The current platforms is an object that has 4 children. These children, I'm thinking 200. Okay, so let's delete the first. Let's delete the platforms for platforms dot delete. Create. Okay, it doesn't matter. I will check the prototype constructor, create multiple, refresh, prototype, add. What's the, oh yeah, create. So we have a clear create contains destroy. Well, let's call the clear one, and we need to remove it from scene. Okay, I will do that. Just give me a second, and I need to sneeze again. But I'll be back. Just give me a second. So, sorry for that. I'm back. Yeah, temporary break. Very short, but it is true. So, let's return to what we were trying to do using platforms, clear, true, and true. I don't know why that, but let's see what arguments we have to pass to clear. Oh, it's refreshing now. And this comes handy if you haven't done it before. Remember, everything in JavaScript it's an object, so you can always look for for the object itself, the prototype. It means where it comes from. If you look for a method, here, for example, I'm looking for the create. I know in this level, it's the one we're using. So we have the clear, remove from scene, and destroy child. Yes, yes. And this probably will break a little bit of the game, but I just want to check if the platforms are clear. Yeah, they do. So that's the great thing here. Let's now create all platforms again. These ones were created. This is the original one, so I'm going to copy and paste this very quick. I will do this first thing uh, because, well, I think it's very important to have a platform. So platform clear, platform create, the original one, and we are duplicating this 3 more times because that's the number of platforms we have. So we have the game again. We can come here. Okay, and that was random. That didn't make sense. We probably are going to face a scenario in which, like this, it's going to be hard to reach the rest of the stars. We can do this. No, no, I probably better get killed. Well, that's a logic issue. That's not anything to do with Phaser or how this amazing tool works. That wasn't me. I probably need to specify or find a way to say like, hey, yeah, do it random, but make coherence of where you can put these platforms or not. Yeah, I'm not able to reach that, so I'm going to reload this, see if now we have better luck on where the platforms are created. Nope, not luck at all. I think I won't be able to reach that amount of stars there. Another thing we can do to work around this, it's messed up with movement in X. For example, collect stars, hit the bomb. No, in the update. So if the cursor is down or up, increase this to 630. So let's reload this and see. Yeah, now we jump much higher. So we probably won't have a problem. Wow, I I don't have a problem reaching these stars. And let's see if we can avoid the bomb. Okay, that's just ridiculous. The game tell me like, hey, you think you're better than me? You think you could get around my okay? But you see, that's how we can start doing these video games. And for example, um, if you're familiar with Arduino or with other uh, game develop. Well, no, Arduino is not a game developer, but I mean, what I want you to have clear and in mind is these two functions here: the create and the update one. The preload it's third, and it doesn't apply necessarily to all game developing. In this case, to the phaser. To the way how phaser works, it is fine, but the create and update one are very common when you develop games because you need to set some things at the beginning, and in other times you need to actively hear what's happening with the user. In this case, the one who's playing the game, you need to hear the instructions, you need to hear the control, you need to make changes based on the interaction. That's what make it a game. If we just have a create one, it will be like an animation. It will be a video game, not a video game, sorry, a movie or something similar. So that's it for the session. I hope you have a really good time exploring with me these amazing tools. Next time, tomorrow, we will explore Play Canvas, which is indeed the game engine, not only a library, not only a framework, but a whole an IDE to help us take our assets, take the textures, take the scripts, take the whole things that compound a video game, and well, create a video game. Uh, so some lettuce for my three favorite people here on chat. Uh, and oh well, you see, and that's it. I just want to leave, but before I leave, I discovered how to do like this balloon thing. So you need to put your put your hands like this, and I don't know why the camera is going to detect these things and put it in party mode. Yesterday I got shocked when I discovered it, but yeah, I just want to share that. Oh my dog! Oh my dog! Oh my dog! I'll let you. I don't know what that means, but I'm going to assume you have a good time. If you don't have questions, I think that's it for the session. We can go. Jackson 62455. That's a cool face. So I'm assuming that means you have a good time and that you learned a lot, and that's what I am too. So thank you all for being here. I'm saying enough. Thanks and bye bye. See you tomorrow for the last part of this series of game developing in JavaScript.